Hi everyone, and welcome to Bash Course Quarantine Statistics. This is episode 2, Confidence Intervals and Sampling Distributions. My name is April. Let's talk about sampling distributions. They are really important in statistics, and they'll help you represent things, but we're just going to go through some of the basics and what connects to confidence intervals, which might be a big part of the AP exam. In statistics, we have this idea that there is the population, this huge group. When we do experiments and surveys, we're often trying to estimate different characteristics or parameters of the population through samples, because in reality there isn't a way to survey the whole population. The closest thing we might have is a census, but ask your parents if they've filled that out yet. The sampling distribution is what you get when you plot a statistic of all these different samples against the frequency of getting that statistic. You will see that this curve formed has differences because samples have natural variation. Even if you're only talking to groups of female 16-year-olds who live in DC, the average number of shoes they have is going to vary sample to sample. But as you take more samples of a large size, you start to see shapes, usually a bell-shaped curve, emerge in the distribution. You can even assume that it is normal as long as the sample size is greater than 30 for means by the central limit theorem, or if n times p is greater than 10 and n times 1 minus p is greater than 10 for proportions. Similarly, when you have a large sampling distribution, you actually start being able to estimate parameters pretty well. The mean value of an infinite sampling distribution is actually the same as the population parameter. Of course, real data sets aren't infinite, so we do other things to find population parameters, such as a confidence interval. A confidence interval is an estimate for the true parameter using a single sample. Since there is natural variation in samples, we produce an interval, a range, rather than a single guess for the parameter. Let's look at an example. Following a record-breaking day when 6 million people nationwide filed for employment, that is true, the rest of the problem is not, a DC Council aide wants to estimate how many people in Ward 7 lost their jobs in order to appropriately formulate aid. She randomly calls 50 phone numbers associated with Ward 7 adults and asks if that person had lost their job within the last month. At the end of the day, 24% answered yes. Assume all those called responded. Construct and interpret a 95% confidence interval for the true proportion of adults in Ward 7 who lost their job within the last month. Alrighty, this is state plan 2 conclude problem, if you didn't know. So, state is like a lot of those where you're basically just rephrasing the last sentence of the problem, making sure to include the confidence level and defining the parameter in context. In the last video, we talked about the conditions random, normal, and independent. They're the same here. Those surveyed were selected randomly. The number of people who said yes is greater than 10, and the number of people who said no is also greater than 10, so this sample is approximately normal. And 50 people is less than 10% of all Ward 7 residents, so this sample can be considered independent. The method is also pretty similar. Single sample, we just did one. Z, because we're dealing in proportions, if you hadn't noticed that already, it's also pretty important to the other parts of the problem. Make sure you establish that first. And interval, because it's an interval, not a significance test. And for P, because that's the proportion parameter. Okay, cool, now into new territory. The most important thing to remember for confidence intervals is that confidence interval is equal to the statistics of a sample plus or minus the critical value times the standard deviation. Lucky for you, it's on the formula sheet. The critical value is based on the confidence level as well as the degrees of freedom for a t-test, so use a t-chart. You need to memorize that 90% is 1.645, 95% goes to 1.96, and 99% to 2.576, but we do know how to find them. These critical values, also called z-star, are basically z-scores associated with the confidence level as a probability in the middle of the sampling distribution. So what is a confidence level? When an interval has 95% confidence, You're saying that if you made an interval from all possible samples of the same size and using the same method, 95% of them will include the true parameter. So let's get back to the formula and plug everything in. You're going to use the same formula for standard deviation that's used for the standard deviation and sampling distribution, as you can see on the formula sheet. We'll be plugging in the sample statistics, so not the population statistics, but population parameters, but we don't have those anyway, so it doesn't matter. P hat here, and then X bar and S sub X for means. Make sure that's S sub X on your calculator, not sigma. Sometimes you might be asked about the margin of error, or you might often read it in an article, actually. Margin of error, it's just the second part of that equation, critical value times standard deviation. With that plus or minus, it gives us a range, an interval. The value at the very center of it is known as the point estimate, which you might notice is the same as the sample statistic that we found. We're not concluding it to be the true parameter. No, we're concluding a range, an interval. Make sure you don't mix it up with standard error, which is another way of saying the standard deviation of the sampling distribution, but using the sample standard deviation instead of the population standard deviation, which you would have in a full sampling distribution. To conclude, we're going to use one of those fill-in-the-blank sentences that helps you hit all the components. We are 95% confident that the true proportion of Ward 7 adults who lost their jobs in the last month is between 12.2% and 35.8%. Make sure that your context is specific, so you're not associating things that shouldn't be associated. Another tip, since the 2020 AP is open note, they'll probably be really testing you on how well you understand concepts rather than just memorizing the facts and the processes. So ask yourself why we did certain steps and how concepts from different units are related. As we remember, significance tests aim to figure out whether an assumed parameter, the null hypothesis, is true or not. So if you compute an interval that contains the value of the null hypothesis, your test won't end up rejecting it. And vice versa, if it's not in the interval, you may reject. And all of this can go back to sampling distributions. The p-value you use to reject or not reject the null hypothesis is just the probability of the test statistic, t or z-score, easily represented in a sampling distribution, where intervals can also be drawn, and you can look for overlap. It's cool. That's it for now. Good luck on your AP. I have confidence in you. Hey everyone, and welcome to Bash Course Quarantine Statistics. This is episode 2, Confidence Intervals and Sampling Distributions. My name is April.